Hey everybody, how you folks doing today? Happy Monday. It has been a while. Wow, since June since we talked. My goodness, because we had the 5th of July off, and then we had the week for the midterm. Hopefully you've got a chance to get that just about done and ready to turn in. Due date, again, sorry for the change of plans, but just I was running behind, so wanted to give you guys as much benefit as I could there. So it's due tonight at 11:59 p.m. If you haven't hit submit yet, go ahead and finish that up and hit submit for me, and I can get those graded eventually. My goodness, I'm sorry for it. It's been a rough summer, but you know we're getting there. We're getting there, and then hopefully fall will look a little bit more normal is the goal. So we do have fall registration open, which is the plan to be the regular fully in-person classes for most of our courses. Only a couple of the CIS courses are actually online. So if we go and look for what's happening come fall semester here in CIS land, you'll be able to see the schedule. So if you are in the software engineering program, which is the one I'm most familiar with, right? We'll be done with the 1500 course, and then you have all sorts of other cool courses to take after that. If you're in, is it the systems analysis, I think, also takes 1500. Then you're done with your coding classes. I've got a lot of 1500s, 3 different ones. I usually do the Monday, Wednesday, Tuesday, Thursdays, and then this Tuesday night one fit best with my schedule come fall. So I'm teaching 3 different 1500 courses, and then the 2454 course, which is web systems development done in PHP and Java. So this one you can take after taking 1500. This one or the prereqs, Java 1 or Java 2, 1500 or 2151 is a prereq. We don't do too much crazy Java programming, so I'm usually fine with people just doing 1500. We start with PHP and then we get into the Java anyway, so it's a little funny like that. Yep, so that one, other courses, the Java 2 2151, you can take that one with Dr. Baugh or one of our awesome adjuncts. I don't know who exactly will be doing that one yet, but we'll find out soon. So Dr. Baugh's class is fully asynchronous online. Oh, but it looks like it's full already. My goodness, that filled up quick with 1 in the wait list. Although 24 is probably the wrong number there. So that may or may not get changed. 24 is for if we were an in-person class. Like usually they're 30 for online classes. So we'll see. Maybe wait list for that, or you can take it Monday nights at the Auburn Hills campus. Ooh, okay. That's fun. No, that's fine, the fan. No big deal. I check your GitHub commit times anyway, rather than the D2L times. Yeah, you'll be fine. Yep, other fun courses, C++. Mr. Nasser is our newest full-time faculty member starting the fall semester. He's been an adjunct for a couple years, and now he's moving into the full-time ranks, joining myself, Dr. Baugh, and Mr. Ian Leith for our Orchard Ridge campus. We've got 4 faculty members now, back up to full strength, which is pretty cool. Data structures. Now, this says all you need is 1500. I don't recommend you take this until you've taken Java 2, or I'm sorry, Object-Oriented Programming Java, which is the second course in the Java track. So definitely recommend you do 2151 first and then come to 2353. We've got 2 of those with Dr. Baugh, who's fantastic. Other courses in the track, I'm not really sure. We could go look and see what else is. Oh, the mobile with Dr. Baugh. That is also online and asynchronous. If you're going to do your mobile development course, which is a lot of fun. Excuse me. All right. So any other questions, thoughts, or concerns? Let's see, what else is Mr. Howdy teaching? That was the wrong button. No. Why? Oh, my function lock's not on. That's weird. C++ projects. Okay. Oh, HTML5. There we go. Hey, it was a lot of fun, Silver Dart. We hit up a Jellystone camp in Kentucky, where actually for the first time I had decent cell service. Usually there's almost no cell service unless like you're up at the ranger station. But I could get great cell service, but their Wi-Fi was just awful. So I could barely get my computer on the Wi-Fi to do anything. So I actually had my phone doing a hotspot to get my computer online instead of their Wi-Fi, and it was faster doing that. So apologies if I wasn't able to make a meeting with you folks. The screen sharing just would not have gone very well at all. So hopefully everything worked out. Going to push the project out a week. And a couple of people had some questions. Wasn't able to get together on screen shares with them. So hopefully that works. So we'll talk about the project today. We'll talk about inheritance. I had wrongly titled it before. I think I've got the right title in here now. Yeah, inheritance is our topic for today. And that is the last topic we need before we can get into building graphical user interface applications and we finish up the semester in our final project. So someone had asked me in chat, I thought I was going to talk about the final project today, but I answered without actually looking, so I was wrong. So if you're really curious, we can talk a little bit about it, but it's not going to make a whole lot of sense until we've talked about building out GUI applications here from chapters 12 and 13. Okay. We've got miscellaneous topics coming up. I want to talk a little bit about exceptions. We've not done a whole lot with them other than when we talk about files, we say, hey, I'm going to throw exceptions. Okay, cool, Amoko. Yeah, so next week we'll assign that. So you've got a whole month essentially to work on it here for the final project. And then for the final project, I would recommend you pair with somebody. Silver, when the scores for them, I'm sorry for the delay. So assume your self-assessment score is good, unless you just totally BS'd your way through that. So I'm assuming you folks assessed yourself fairly and correctly. So you should assume that's your score. I'll be working on them. I got a big backlog because it's been a really rough summer. My apologies. Happens every time. Things just, life is busy. So I'm sorry for the delays, but assume your self-assessment scores are good. And then hopefully that makes you feel better about it. Yep, so we wrapped up our last individual project with project 3 tonight. We'll talk about the solution to that. That'll finish out your project scores. Chapter 10 will be the last chapter quiz that we have. Actually, we might do one for 12. There's not a whole lot to do on chapter 13, but maybe we'll do one for chapter 12. So we'll have like 2 more quizzes to wrap up, and then it's just the final project. And that gets us everything then for the overall score, right? The individual projects make up 35%, the quizzes make up 10%, the midterms 15%, and then 40% for the final project. So I do recommend if you can find somebody in class who you can coordinate schedules with to pair up, that's fantastic. If we can't, because this remote learning is hard, I get it. You don't need to work in pairs. Usually that is a requirement, but again, that's just optional here. Individuals and pairs will do the same work, or the same project. There's not more work for working in a pair, because you actually get a little bit of extra, it's extra work doing the coordination and making sure people are working on the right things and you're collaborating properly. It's hard to say, hey, you do this thing, I'll do this thing. Like when you write an English paper, you write this portion of the paper, I write this portion of the paper, we just slap them together and it's done. It doesn't really work like that with software. So a pair does have more work to do. So that's why the actual deliverable, the project itself won't be any different, whether or not you're in a pair or individual. We'll use the stuff from chapters 12 and 13 on it. On the night of 8/16, I don't have any plans to do any lecturing. That's just time set aside. I'll have extra office hours that day, or that night. If you folks want to get together and meet to talk about what's going on in the final project, I can get together with your groups or pairs or whatever if we want to. And then on 8/23, so coming up just a little over a month now, we'll get together on Zoom, not here on Twitch, and everyone can present their final project. And, what's fun about that is we get to see how everyone approaches it differently. When we start building applications, right, part of this programming is an art. It's not all science. And there's an art to how we design things, how we lay things out, how we make things look. There's all sorts of really cool things that go into that. So we can see how everyone's is different from ours, but they all accomplish the same goal. right? So this is what it has to do. It has to, check this box, check this box, check this box. Oh, these are the things the project's going to do, but everyone's going to approach it differently, which is fun. So I've given example screens before, but when I do that, people build what I show them, and it takes out some of the fun. So I tend to try and not give you, hey, here's how I did it initially, because part of the interesting piece is, well, how do you come up with your designing your solution? What's it going to look like? So if you get stuck on something, I'm happy to show you, but it's cool to see the different takes that people have on it. So, all right, yeah, we are winding down here now. So we've got 3 more chapters of content. We're not going to do all of chapter 10. Again, you'll hit this topic a lot harder in the Object-Oriented Programming Java course, the 2151, or Java 2. And then 12 and 13 will hit most of 12 and most of 13. And kind of pull out some of the highlights. We're not going to need to use all of the tools from 13, so that'll save a little bit of time. And then we actually go and use Scene Builder to save us all sorts of work. So I'm going to show you next week how to install all those tools that we need. The additional links here was the OpenJFX link here and Scene Builder, 2 little products here from Gluon. That we're going to use. So I'll show you how to install those and set them up. And then we can actually build out our graphical user interfaces, which is a lot of fun. All right, so when we talk about Project 3 first, and then we'll get into Chapter 10. How's that sound? Yeah, the number of submissions went down. Oh, I guess maybe there's a multiple submissions. Okay, so we're pretty steady at 23, 22, 22 people submitted. Okay. Did have a couple of people drop, which it happens. All right, so we're going to write our class for electric vehicle. It's going to have attributes. We're going to have get methods for all the attributes. We're going to have a set for color. The constructor should require, oh, I didn't say color there, but I think I did in the rubric. Yeah, the constructor should accept color. So if you didn't put color in the constructor because this says not to, you're fine. If you did because the rubric said to, great. Both ways are fine. As long as you have the set color, you can set the color. All right, sorry for the mix-up there. All right, so let me fire up NetBeans, and we'll write our little electric vehicle class and see if we can write some unit tests for it. Because any code that's worth writing is worth testing. Because if someone's going to pay you to write code, they're going to want to make sure the code does what it's supposed to do. And the computer is much better at testing things than people are, at least at this unit level, right? In terms of once I have an entire system built and, an end-to-end test everything that this thing does, sure, there's more to it than that. But we can unit test to make sure our individual methods do the things that they're supposed to do. Oops. All right. So we'll call this Project 3 in 1500. I like it. Got the right folder. And this main method here, we don't actually use. We're just going to ignore it. Really got to take out those templates. We just leave it there. We don't need anything in here. But we're going to come over to our little explorer here. We're going to go to our package and add a new class. We're going to add the electric vehicle class. I probably misspelled that. Vehicle. Yep. So if you refactor rename, it will rename the file for you as well. HICLE, excuse me. There we go, because remember, the name of the file needs to match the name of the class. That's our rule for Java, for public classes. All right, so electric vehicle. It was going to have a couple attributes. We're going to have a private string for make, a private string, oops, sorry, that should be lowercase. Private string for model, a private string for color, a private double for, what else do we have here? Kilometers per kilowatt hour. In lowercase, we're going to have a private double for max kilowatt hours in battery. And we're going to have a private double for current kilowatt hours in battery. Right? Okay, so we got a bunch of attributes here, but each instance of electric vehicle will have its own set of these values. So my Chevy Bolt that is gray has a certain number of kilometers per kilowatt hour. Mine's in miles now. So what's 3? which is so weird that we mix things up like that. 3 times 1 point. Oh, goodness. Not the programmer calculator. 3 times 1.6. So I get about 4.8 kilometers per kilowatt hour in my gray Chevy Bolt. The max kilowatt hours in the battery. Oh, man. You know, it shows me in miles, not in... So 4.8... is it like 270 divided by 4.8? So I have about 56 kilowatt hours in the battery, I'm guessing. So your attributes should not be public. Yep, so we should be specifying these are private attributes, because the idea is that my class has access to them, and I will give you public methods that you can use to access these values. That's the idea of encapsulation. We're going to take all of our details and hide them away in our class, and then you're going to interact with my class in the abstract way, with abstraction, through the public methods. We're going to run a bunch of public gets. So public string get make returns make. A public string model get model returns the model. A public string get color that returns the color. A public void for set color given a string for color. We'll take this color, right? Remember that this is my instance attribute equals the color argument here. So notice I get some cool coloring here in my IDE. So I get orange for the argument variable, and I get green for my class level attribute. So that this dot is my instance equals the color that you give me. So only colors getting the set. These other ones here aren't going to have set methods, because it is once you make it that class, it's probably not going to change. So it's a get kilometers per kilowatt hour, return kilometers per kilowatt hour, and max. We'll do a public double get max kilowatt hours in battery. Oops, that's the wrong curly brace. Return max kilowatt hours. And I'm just doing a bunch of copy pasting here because I don't like typing if I can help it. Public double get current kilowatt hours, capitalize that. And we'll return current kilowatt hours in battery. Okay, so far we have our attributes. We have get methods for all the attributes and a set method for color. Now we're going to write a constructor. The constructor's job is to give all of these attributes values. And usually the constructor goes first. Again, there's all sorts of fun conventions, but typically your constructor will go first in the class. Some people say you put these last, some people say put them first. Whatever organization you end up at, just follow their standards, because life is easier if everyone does things the same way. You just get used to looking at code that way. So I don't think the rubric, did the rubric have points for those being private? I can't find the cap. There it goes, got it. Let's see. All attributes have a get method, set color accepts a color, charge method, drive method, unit tests, unit tests, unit tests. Okay, so I didn't specify. They should be private, but you won't lose any points for it if they weren't private. So no big deal. Anyway, our constructor. So the constructor is special. Remember, it does not have a return type. It's not void or anything. It's just public name of the class. Now we can list our arguments. So I need a string for make. I need a string for model. I need a string for color. Again, if you missed that because you followed these directions and not this one, that's fine. Either way is okay. String for color. We need a double for kilometers per kilowatt hour, and we need a double for max kilowatt hours in the battery. So if you give me all of those values, I can make an instance of electric vehicle. So like this make equals the make. Like this model equals the model. Like this color, and now actually I don't want to do that. I want to use set color. The only reason I want to do this, I mean, color we know doesn't do anything fancy, but other methods that have set methods, you might do some sort of thing like, hey, this is a valid value. Remember, I think when we did set grade for students, we made sure it was no more than 100 and no less than 0, because the set method was doing that logic. And you don't want to have the logic twice. If you have the same code twice, you should feel bad about yourself. Right, so if you have a set method, just use the set method. It's easy. And then a this dot kilometers per kilowatt hour is the kilometers per kilowatt hour, and the this dot max kilowatt hours is the max kilowatt hours. Max kilowatt hours in battery. Okay, so we're setting all of our instance attributes, but we haven't set current yet. So what value should current be? Well, I'm going to say you get an uncharged car. So we're going to set that to 0. Because if you wanted to give it some initial charge, sure. If you want to make it full, that's fine. Whatever you wanted to set it to. For me, I'm going to say it starts at 0. Or maybe we start it at max. I don't know. Should we start it at max? We could do that. We could start it at max and say, hey, when you get a new electric vehicle, it's fully charged. Wouldn't that be nice? Might save the, I don't know, $2 of electricity or something. Yeah, fun story. When I bought my Chevy Bolt, it was not charged fully, and I did not have a fast charger at home. So I went and I drove it home, and I plugged it in at home, and it started charging overnight really slow. It only charges like 4 miles worth of charge per hour at a regular outlet at home without the fast charger. And then my wife had to go somewhere. She's like, hey, can I drive the new car? I was like, yeah, go for it. So she went and did everything, and she came back, and we started charging again, and I had to drive out to U of M Dearborn for class. And it had about 35 miles worth of charge on it. And from my house to U of M Dearborn is about 30 miles. It's like, oh, that's not very good. But turns out they do have chargers on campus there. So while I was on campus, I could charge the car to get it charged up enough. They have fast chargers, which charges like 20-something miles per hour, or 20 miles worth of charge per hour or so. So I was able to charge up enough to get home to start charging again. That was quite the day, quite the adventurous day. All right, anyway, so our constructor is setting these attributes, right? So now we have our constructor. Cool. All attributes have a get method. Cool. Set color accepts the color, sets the vehicle color to that color. Great, because you can, the idea with this, not all methods, not all attributes have to have a set, because like once you have the make and model set for something, it's probably not going to change. My Chevy Bolt will always be a Chevy Bolt, but if I get tired of it being gray, I can go pay some money and paint it, right? And make it change the color. So that'll happen, right? So things that should be changeable, you can have set methods for. Things that don't change, you don't need set methods. All right, and now we're going to do charge. So we accept a kilowatt hours variable, update the current kilowatt hours and battery attribute if it's not negative, and ensures it does not go above the max. So we're going to write a method here for charge. So public void charge, given a double of kilowatt hours. Now someone told me it had 2 T's, right? Yeah, kilowatt hours. So if it's not negative, so if kilowatt hours is greater than 0, let's do something. If you try and give me a negative number, well, I don't want that to happen, right? Part of why we write classes is we're encapsulating all of the details and we're protecting the integrity of our class. I should make sure that my value, my attributes are always valid. And if you give me a negative kilowatt hours and I just say, hey, current kilowatt hours and battery plus equals the kilowatt hours you wanted to give me, if you gave me a negative number, you just did a bad thing, or I just let a bad thing happen. So I'm making sure that, yes, this is a positive value here. Okay, so if you give me something positive, I'll add it. If it's not positive, there's no else, nothing else happens. There's just, I ignore you. Nothing happens. Then I want to check that if my current kilowatt hours is greater than the max, right? Oops, that's not allowed either. We're going to say my current kilowatt hours equals the max. So if I charge more, so say, hey, you told me you wanted to charge 200 kilowatt hours and I can only fit 50. Sure, I'll add 200 and then I'll say, oh, did you go over the max? Sure, well, let's bump you back down to the max. Pretend that didn't happen. That's it for charge. Okay, so ensures it does not go above the max and updates the attribute if it's not negative. So that's charge. All right, now drive was supposed to return a Boolean result of whether or not you were able to drive the distance or not. So that's a Boolean, a true or false. So drive, a double of kilometers. How many kilometers do you want to drive? Veda, we talked a little bit about registering for fall semester, and what else do we do? No new information yet. We're going to cover chapter 10 after this, Veda. Yep. So for drive, right, you tell me how many kilometers you want to drive. Now we should probably do the same thing, right? So now I didn't specifically ask for it, so it's fine if you didn't have it there, but I'm going to do the same thing. If it's greater than 0, let's go do this. Right? Because if you give me a negative number, my arithmetic is going to be really funny, and I'm going to do a bad thing to my current charge. So if it's greater, awesome. I'm going to say double, it says kilowatt hours required is equal to the kilometers divided by the kilometers per kilowatt hour. So if you want to drive 100 kilometers and you get 5 kilometers per kilowatt hour, that should be 20 kilowatt hours that it needs. Okay, so it's going to tell me how many kilowatt hours I need. Then I can take my current kilowatt hours, subtract that. Now, you don't need to do it in 2 steps. You could just subtract this arithmetic. Perfectly fine. Either way is okay. I think this way kind of is very clear about why we're doing this arithmetic. And we have a nice name for it. Okay, that's the only reason. So could just be all one line, or we could have the value and then subtract it. Cool. Then we're going to say, hey, if my current kilowatt hours, if that's less than 0 now, oops, that's no good. I can't have a negative charge. I'm going to set it at 0 and I'm going to return false. You were not able to drive the 1,000 kilometers you requested. I did not have enough charge for 1,000 kilometers. I had enough charge for whatever the distance was, but nope, we ran out of charge. Took too many. So make sure my current kilowatt hours in battery is a valid value. Make sure it doesn't go negative, right? Because you can't have a negative charge in a battery. Right? Otherwise then, so now at this point, I could put an else in, but it's sort of redundant because if this return line runs, remember the method stops. It's done. As soon as we hit a return, no other code runs in the method. So the else here is totally optional, so I'm not going to bother with it. Otherwise, I'm just going to return true and say, sure, this worked. I subtracted the kilowatt hours required. You didn't go negative, so yes, you're able to drive the distance. Life is good. Why is it upset? Oh, okay, so it's upset that it was not... there's only will return if this is true. So if this is not true, my method doesn't return something. So I'm going to then say return false. If you give me a negative value, I'm going to tell you no, go away. What do you mean if we don't set true? So we're saying that when you call drive, it will tell you true or false here. So either you couldn't go far enough, you could go far enough, or I'm telling you no because you gave me a bad value. Okay, so let's drive. So it figures out how many kilowatt hours we need, subtracts it. If we went negative, we couldn't do it. We ran out of juice. Oh, it turns out, I just saw this in the news. This was funny. Ford Motor Company patent for charging electric car via towing it. Yes. There's a patent they filed in December of 2020 that they can charge your electric vehicle by towing it. Right, so one of the cool things it has is regenerative braking. So as you're braking, most hybrid vehicles or electric vehicles now will turn some of that kinetic energy into electricity and charge the battery. So you can essentially just do that as you're pulling it along to give yourself some charge. So your tow truck doesn't need to come and bring a generator, right? Instead of getting you a can of gas, it can just tow you a couple miles till you get enough charge to make it to a charger or something like that. But I saw that in the news. That was really funny. Okay. Oh, okay. You saw where we returned false. I gotcha. Cool. All right. So I think then in terms of the specs here, we have all of that. Our drive method, kilometers to drive, reduces the current kilowatt hours, ensures it does not go negative, returns Boolean based on if you can drive that far or not. Now we need to write some unit tests. The idea with our unit tests is we wanted 100% code coverage. We want to make sure that every line of code runs when we're testing it. Remember, 100% code coverage is a fantastic goal. We should get there if we can, but you don't always, and we're not going to feel too bad about that. But the idea with that is if I'm writing a test and I never check that when I go negative I get a false, then I have no confidence that it should do what it's supposed to do. Right? So I need to have a test that will, yes, I will get a negative value, I'll set it back to 0 and I'll get a false, and I'll have a test where, yeah, it just drives the right amount and I get a true. And then I'll need another test where I give it negative and I get a false back, because I want this line of code to run as well. For charge, right, we need to give it a positive value, and then make sure if we charge over max, it stops at max. So technically, just one test there will test all of that. We'll get 100% code coverage. But we might want to have, hey, does it charge a regular amount, and does it charge over max? Both are fine. So we're going to right-click the class, say navigate, go to test, Make sure you pick JUnit 4, because that's what works with Java with Ant projects. Don't check anything else, okay? All right, so we have a couple. I don't need any of these gets here. Set, technically, because our constructor's calling set, we don't need to test it separately, right? We know that's happening. So all we need is charge, drive, and then an at test for test constructor. Okay, so we're going to arrange. So we're going to have a string for make, Chevy, a string for model is bolt, a string for color is gray, a double for, and you know what, I should just go copy these here. Kilometers per kilowatt hour, what did I say, 4.8 or so. A double for max is, what did I say? I think I had like 48 or so. I don't remember, or 50. I don't know. Sure, why not? Okay, so these are the values I need to create them. So in my act now, I'm going to make an electric vehicle. I don't know, we'll just call this car or vehicle. Sure, vehicle equals a new electric vehicle. We're going to call that constructor. We're going to give it the make, the model, the color, the kilometers per kilowatt hour, and the max kilowatt hours in battery. So that got a little long here. Let's bring that down a line. Right? Kilometers per kilowatt hour, max kilowatt hours in battery. And then we're also going to have a double for our expected current kilowatt hours in battery. So what should the current be? And we said ours should be the max here. So I'll just set it to max. So these are all the things I need to make it, and then I'll know, hey, this is what the charge should be after I call the constructor. So we create an instance of vehicle, and now we're going to have a bunch of actuals. So we'll have a string for the actual make, and then we'll use that get method, vehicle.getMake, to see, hey, what does this instance of vehicle think its make is? And we'll do get model, and we'll do get color, actual model, and actual color, get model, and get color. Okay, so these are what this vehicle thinks after we've called the constructor. Right? They should match if we did everything right. And then we're going to have a double for actual kilometers per kilowatt hour, vehicle.get kilometers per kilowatt hour. Cool. We'll have a double for the actual max kilowatt hours in battery, vehicle.get max kilowatt hours in battery, and then a double for the actual current kilowatt hours in battery, vehicle.get current. Get, I misspelled vehicle, vehicle.get current kilowatt hours in battery. So that's all of these get methods are being used to see, hey, what are the values? So we're kind of testing all of the gets all at once here. So this is the constructor. We know the constructor is also using set colors, so we don't really have to do it separately. If you want to do it separate, that's fine too. Okay, so that's our act, and we're going to assert. Now we'll have a bunch of asserts. So assert equals the actual make, or the make and the actual make. Right, the model and the actual model. Color and the actual color. A bunch of these other ones. So actual model, actual color, so model and color. Color. And then these ones here, the kilometers per kilowatt hour. What's up? The Kindle? I was downstairs, I thought, in the back room. Did you use it? It should just be downstairs then. Take a look, maybe we can bump up the table. All right, and then our actual kilowatt hours, and then the actual here. Let me go grab these ones. Max and expected. I think I usually called all those expected, but I got tired of typing all that out. So we're saying, hey, do they match? Now, the problem, when you're comparing doubles with assert equals, it's going to yell at us here when we test. We'll take a peek. Because when you're comparing doubles, remember, Java's really bad at math. So when you compare doubles, it says, oh, we need to have a delta here when you compare floating point numbers. How close is close enough? So we'll say like 0.0001. As long as you're within whatever that is. That's a tenths, hundredths, 10 thousandths, 100 thousandths, a millionth, right? Tens, hundreds, thousands, tenths, hundreds, thousandths, 10 thousandths, 100. So if you're within 100,000th of the number, we'll call that close enough, and I'll go test. And it passes. Okay, now notice the other two pass. If you don't fail, you pass. Should sort of make sense, I guess. That's a nice default. But that's our test for constructor. So if we call the vehicle constructor, do we set the proper values? Because what happens sometimes is sometimes you typo these things and you'll say, oh, the max was actually this other one, or something else happened. It's really easy to typo things. So this is our check that when I give it a bunch of values, do I get them back out again? Okay. Now for charge. Okay. Now the problem with our vehicle is we're already charged to max. So that's sort of a problem here. So charging will be tricky here if we're already set to max. Maybe we should just set it to 0. Maybe we set it to 0 here. And I'll say my expected should just be 0. Let me do that. Let me leave it at 0, because otherwise charge is going to be really tricky. Okay? All right, so for charging then, I'm going to do this same sort of thing here. Arrange, act, where I go make a vehicle. But I don't actually need all of these other values here. I don't really care about make, model, and color. These ones are the important ones. So I'm just going to just say empty strings, because we don't care. You could put in all the other ones, you could leave them, doesn't matter, but I'm just going to say they're empty for now. We're going to say, actually for charge we don't even care either, but max matters. So if we go charge, let's just charge 20 kilowatt hours. We'll say, if I charge 20, right, that's what I should get. So I'm going to make a vehicle, and I'm going to call charge. Vehicle.charge, given the expected kilowatt hours in battery. And then I'll have a double for actual. Actual current kilowatt hours in the battery is vehicle.get current kilowatt hours in the battery. So let's go ask it. So we'll try charge, and we'll go see what value we got back out. And then we can assert that they're the same. Right? So if I charge 20, did it go to 20? All right, that one passes. So now we're going to do it again now, because remember, charge, we want to make sure we get this line of code to run, because with that test, this line of code didn't run. We didn't charge over the max. So I'm going to try that again here. I'm going to copy paste, change the name, test charge over max. So my expected then should be the max. And I just need to go charge. Let's just do like, how about max times 2? If I charge double the max, sure, it should stop at the max. We're going to run this test. Cool, that one passes. So now I feel like I have 100% code coverage in charge because we've tried a regular charge and we've tried an overmax charge. Again, technically just the overmax charge runs every line of code in here. So sure, that's fine. Okay, now we're going to try drive. So we need these ones here for drive. Okay, so I'm going to go charge some amount here. So how about we charge the max? And then we'll say, hey, if I'm going to go drive a bunch here, what should my charge be after I've driven? So let's put this down and say, how about 38? If we want to use 10, let's just go down 1. Let's do 47. So if I drive 4.8 kilometers, it should use 1 kilowatt hour. If I started with 48, if I charged it up to the max, then I should have 1 left. So I'm going to call, I need a Boolean result, right? So I'm going to check the result too, is vehicle.drive. We're going to call that drive method. And we're going to tell it we want to drive the kilometers per kilowatt hour. So if we drive that many kilometers, it should take 1 kilowatt hour. 48 minus 1 should be 47. So we're going to assert that that one matches, and then we're also going to assert true, that my result is true. You could say assert equals result and true, but this is a little bit shorter to type. So it should tell me, yes, I can drive that far. I was able to. Let's give that a check here. Oops, that's why. Test drive. Too many curly braces. Okay, that's a little better. So see if test drive works. This is a regular drive. Okay, took away 1 kilowatt hour. So we're going to do it again where we drive over the max. Right? Over max or something like that. So we should have 0 charge left in the battery. If I try and drive, I don't know, let's drive, what, kilometers per kilowatt hour times 1,000 or something? I don't know. Sure, just some big number. And then my result then should be false, because it should say, no, you can't drive that far. And that one passes. So I've got 100% code coverage of my drive. Oh, I don't have the false here for negative. I'll do one more here. So for negative. So the expected then should be the max. That shouldn't change if we give it a negative value. If we give it like -10, nothing should change. So my battery should still be at max because I charged to max. All right, that one passes. Cool. Hey, Snakeblood. Merry Monday to you too, sir. Thanks for dropping by and donating your subscription to the Student Scholarship Fund over at the University of Michigan Dearborn, where I'm both a student and a lecturer. It's pretty cool. Right, hope your summer's going well. So I think now we have 100% code coverage with that last one, this last return false. We tested all the gets, right, because we've used all these gets to get the values out, and we tested the constructor. Feel pretty good about electric vehicle. What'd you guys think? You folks think? Tested drive, tested charge, tested our constructor. This constructor's also testing set color. If you want to do another test for set color, we could. That's fine too. We can make one and then change it. That's okay. But I know when I pass it gray, it's getting called in the constructor. Do you spell gray with an E or an A? I think both ways are fine, right? Gray versus gray. Look at that. It's even a search suggestion. AY is the more common US spelling. Really? Interesting. One's American and one's English. You know, I think I drink Earl Grey tea. It is one of my favorite flavors of tea. So I wonder if that's why I usually spell gray with an E. Interesting. The unit gray. What is a gray unit? Huh. Interesting. Anyway, that's what we got for Project 3. So let me go ahead and commit that. 1500, yep, 1500. Project 3, we're in good shape. Project 3, I'll commit and push. The more you know, starring Professor Chernesky. Hey, you can learn other things while learning to code. It's amazing. All sorts of fun factoids. All right. No, she asked me where it was. I thought it was on the table downstairs. Yeah, they were all stacked on the table yesterday. Okay. It'll be a while. All right. Awesome. Discard changes. I didn't think I made any changes, so I'll say yes. All right, so we have Chapter 10 to talk about tonight then. And then we can wrap it up. Do you folks want to take a break now so we don't have to take a break in the middle of Chapter 10? What do you think? Because usually we break at 7. We're a little bit early for break. We could break now, and then we could get through all of 10 and call it a night. Sure, okay. I'll vote for break now. I like it. So let me put some music back on. And we'll come back in about 10 minutes or so. Break time, we'll come back at, it's going to be, what, 6:58 or so? No, I had trouble, Snake, with the Spotify I was using. It kept giving me sound strikes and saying I was using, even though it's like copyright-free music. So this was Shaping the Silence, another Twitch streamer does his music for free, or DMCA free music. All right, I'll be back in a minute. Go get yourself some coffee. Hey, folks. Alrighty. Alright, so we're going to talk a little bit about inheritance. Again, we're not going to go super deep through the whole chapter. We're going to touch on the highlights of it because we use inheritance when we build GUI applications. So that's why we need to talk about them. Okay? So let's do this. Let me start up a new project for chapter 10. And we can go from there. So the idea with inheritance is it's another fundamental of object-oriented programming. And what it lets you do is take one class that already exists and you inherit from it, or you extend that class. So you make a specialized version of that class. So again, inheritance, it's kind of a common topic, like with object-oriented programming, we work with nouns, and nouns have attributes, and those attributes have ways that you interact with them. So we borrow a lot from the way that we're used to talking about things. So inheritance is a known topic in the real world, right? We work with inheritance all the time in that it makes that is a relationship. So when you have a broad category and then you have specialized categories, you still are the type of the broad category, but you're a specialized version of it. So if you talk about like a tree, right? So a tree, then if I just tell you what a tree is as a noun, you have some idea, but you don't know, specifically which kind of tree it might happen to be. Now, we might have inside of the tree broad category, we might have deciduous trees, and we might have coniferous trees. Right? There's two types then, two broad types. They're still all trees, but they're separate there, but they're specialized version of the generic tree. So if we go write a tree class, let's call this tree. And then what do we know about trees then? Trees probably have a private double for height in meters, probably. They probably have a string for color, maybe? Or, I don't know, bark color. How about bark color? And how about a string for leaf color, maybe? Okay, so we'll need some set and get methods for those. So height should change, but maybe we want a set or maybe we want a grow. So maybe grow is better here. So we'll make a void method for, we'll do all the gets first. So get height in meters returns the height in meters. A public string get bark color returns the bark color. And a public string get leaf color. Oops. Returns the leaf color. Sure. And then the bark color and leaf color, maybe those change. Maybe we could set those. I know for some trees, the leaves for sure change. Bark may or may not change colors. I don't know, but height that would grow. So maybe we have a public void set leaf color that takes a string for color. And then we'll set my leaf color is the color. Do you think bark color changes? I don't know. It probably doesn't change. Your bark color probably stays the same. But how about the height? So we need a way to change that. So we'll have a public method here called, we'll make it void. How about grow? And we have a double for meters to grow. And we'll take my height in meters plus the meters to grow. Well, we really only want to do that if the meters to grow is positive, right? So if it's positive, grow. Otherwise, we're not shrinking. Most trees don't shrink. Pretty sure that's a good rule. Right, so trees have a height, they can grow, they have bark color, they have leaf color. I don't know a whole lot else about trees, but that sounds pretty good. Now what we can do is we're going to write another class that is a tree, but it's a specialized version of it. So we're going to use inheritance to say, I am a tree, but I'm a special version of it here. So we'll write coniferous trees, coniferous tree. Now the keyword here, what we use, is when we define the class, right here, this line, public class coniferous tree, we say extends tree. So right now we are a tree. So this creates that is a relationship. We are a tree. We're a special version of it here. Right? Now, we don't have as a constructor, though. We probably want a constructor here for tree. So let's write a public tree that takes a double for height in meters, takes a string for bark color, and a string for leaf color. So we'll say my this height is the height, my this dot bark color is the bark color, and my this dot leaf color is the leaf color. Okay, cool. So we'll take all those. We have a constructor. Now we make a coniferous tree. Now, it's upset with us now, as we go to our action items here. It says the constructor tree in class tree cannot be applied to given types. So what happens is when you make an instance of coniferous tree, it needs to call its parent class tree constructor. So you'll hear a lot of terms. You'll hear parent class and child class. You'll hear superclass and subclass. You'll hear base class and derived class. All of them are perfectly fine. I try and use superclass because there's a keyword here for super, which is the superclass. So if my tree has a constructor, I need to call it because it needs to be able to set these values here. So sure, I need to call that constructor. So we're going to write a coniferous tree constructor. Coniferous tree. That takes a string for, a double for height, a string for bark color, and a string for leaf color. What we need to do then is we need to call the tree constructor. Let's use this super keyword. Let's say, hey, call my superclass constructor and just give it these things here. Height with a T. So you can call your superclass constructor here. So this calls the tree constructor. If you're going to do that, it has to be the first thing to call your superclass constructor. And notice it only yelled at us when we added a constructor for tree. So if you don't have a constructor, remember you get a default constructor from Java, which is terrible. You don't want that. So if there's a default constructor with no arguments, it will take the no argument default constructor. But because we have a constructor with arguments, we have to call that one. So now it's happy here. So what makes coniferous tree special from a regular tree? Well, we have cones, right? So we're going to have so maybe an attribute for an int number of cones. And then we'll say, hey, my number of cones will start at 0. And then we will add a method here like, void grow cones, int number of cones. We'll take my number of cones plus equals the number of cones, my this dot number of cones, plus that. And really, we only want to do that if that's positive. Number of cones is greater than 0. If it's greater than 0, great. Go ahead and add those cones. And then maybe we have a method for drop cones or something. Drop cones, int number of cones. Oops. Right, we do the same thing here. But we're going to subtract this time. We'll subtract the cones. We'll add the cones or we'll drop the cones. Okay? So that's what makes us a special type of tree. So not all trees have cones, just the coniferous trees. Okay? Then we can also then write another class here. Let's write a deciduous tree. That's probably close, but spelling doesn't actually matter, right? So we use the extends keyword. So we extends tree because we are a tree. Now we need to call that constructor. It's upset that we don't have that. So we're going to do the same thing here, where we call our superclass. So you tell me the height, the bark color, and the leaf color. We'll go set that. Okay? Now, what is deciduous tree? What makes a deciduous tree different than a regular tree? Well, we've got the leaves can change colors. Sure, we could already set the leaf color. Maybe we have the number of leaves. I don't know, we could have that. So int number of leaves starts at private int. Sorry. Private int number of leaves. Did I make that private? Yeah, good. Number of cones. Maybe never read. Oh, get. We probably need a get method for it. Public int get number of cones. Return number of cones. Okay, now it's happy. So the number of leaves. So when you make a brand new tree, maybe we'll say starts off at 0. I don't know, and then maybe we grow leaves or something. Void grow leaf. Grow leaves. Int number of leaves. So it's similar to the cones, right? But not exactly the same. And then a drop leaves. get number of leaves. Oh, and we should do that, right, if it's positive. Right, we'll do the same thing for drop leaves, but we'll subtract. Oops, subtract instead of add. That should be an add. Okay, so we can add leaves, we can subtract leaves. Nice. We found the missing Kindle for my daughter. It was in the older sister, underneath the older sister's bed. Suspect some shenanigans. Get number of leaves, return the number of leaves. Sure, so this is just some basic, not anything super interesting at this point, but it sort of follows this idea that the way that we talk about code is sort of using our natural language, the way that we're used to thinking of things in the sort of hierarchy, right? So you might talk about, hey, I'm going to write a class for person, and person is going to have name and probably a phone number, that sort of thing, right? And then it might have a subclass for student, and students will have additional information. They're a special version of person. All the things about person they share in common, sure. But then they'll have additional attributes, they'll have additional methods, they'll have some other interesting stuff they can do. And then maybe I'll write another subclass for faculty, right? And then faculty will have its own set of interesting attributes, that sort of thing. Either one's fine, Undecked Wig. Copy paste is probably easier, but if you're comfortable with GitHub, go for it. Yeah, for sure. I wasn't going to require GitHub at all, because that sounds like it'd be more trouble, more things that could go wrong for people. So I figured people would just copy paste. All right. So other cool things we can do. Let's make another class here. How about we do a rectangle? Right, rectangle is a nice boring example here. So a rectangle has, no, I'm sorry, not even rectangle, sorry. Let's start with polygon. So a polygon, right, just a some number shape here, has a private int for number of sides. And we're going to have a private array list of type integer for side lengths, right? So you can tell me the length of each side. We'll just keep it in an array list here. And when you make a polygon, you have to tell me the number of sides. So my this.number of sides is the number of sides, and my side lengths equals a new array list of type integer. So you can make a new one. Great. Now we need to be able to set side lengths. So public void set side length. Give it an int side index. Remember, we use indexes here where 0 is the first one, right? And then the int length. Well, when we make this now, we need to go fill it up with a bunch of zeros. We're going to say for int side index is 0. Side index is less than number of sides. Side index plus plus. We're going to take my side lengths and we're going to add a 0. So if you're using an array list, right, you don't get default values there. So you have to go add all the zeros for us. If you're using a regular array, then we'd have default zeros, right? That's the one downside with array lists. They don't come pre-sized. So we need to go add that many sides to it, right? If we're doing an array instead, if we had int array of array side lengths, you just say it's a new int array of size, number of sides, and then that would work, right? It would fill them all in with zeros because 0 is your default here. That's okay. So I'll just leave that commented out. So for setting the side lengths, we're going to take my side lengths and we're going to set the side index to the length. Nope, not side index, side lengths. Type the wrong one for me. And length is spelled wrong. My goodness. If we're using this array of side lengths, right, it'd be array side lengths at side index equals the length. Right, different notation, but similar approach. And I prefer array lists because I think they're better. Well, that's just me. A int get number of sides, and return the number of sides. All right, so we can set lengths. We can set individual side lengths. We could get side lengths then. So public int get side length. for an int side index. We're going to return my side lengths dot get the side index. Whatever value is there, let's get it back out. Right, again with that array notation, and we return array side lengths at side index. So either one's fine, right? No big deal. Right, we okay so far? So then what we can do is we can do something more interesting, like calculate the perimeter. So how about public int get perimeter? Now, this is a calculated value. I could keep a perimeter attribute and keep adding to it every time you set the side length. But that's a lot of work, right? And then if I don't do it right, I don't know, it's prone to error, and we can just calculate it. We can just say for int side length, in side lengths, right? This enhanced for loop, this little read only. We need a int for perimeter, starts off at 0. And for every side length in the side lengths array list, let's add the length. We can return the perimeter. Right? We're just going to add them all together. Now, this helpful little thing here, this functional operation, is obnoxious. I don't use it. I think it looks ugly there, but it's okay. Right, so we can add up all the side lengths and return that as the perimeter. Cool. So that's a polygon. Right? So any number of sides, you can calculate the perimeter of a polygon. Any sides. Now with rectangle, rectangle is a type of polygon, so we can extend polygon. Now here's where it's interesting. So the Polygon constructor wants the number of sides, so I have to call it because there's a constructor. You can't not call it. That's what it's yelling at us here, saying we have to call the constructor because it's trying to give it no arguments here. With it no, so we need to call our superclass constructor, and we're going to tell it, hey, I have 4 sides. Because all rectangles will have 4 sides. Right? Why is it upset? Oops, that's got the end of constructor. Public rectangle. There we go. So a rectangle will have 4 sides. Cool. Now the other fun thing that you get, because a rectangle is a polygon, here in my chapter 10 code, I can make a rectangle, small rectangle, equals a new rectangle. And we can go set some side lengths. So small rectangle dot set side length. Let's set this at 5. And we'll set this one at 10. Ooh, uh-oh. Should I be able to set individual side lengths? No, that's not great. Yeah, that's all right. We can get into it. So if we don't like this version, we can change the version of our superclass. So polygon set side length does this. Rectangle, we can change set side length. So we can do this thing called an override. We're going to say, hey, I'm going to change the behavior of that method. So set side length, given an int side index and an int for length. So I don't want you to be able to set one side different than the other side, because with a rectangle, both top and bottom need to be the same, and both left and right need to be the same. We're going to say if the side index is equal to 0, or the side index is equal to 2. Now, if it's 0 or 2, I want to set them both. So I'm going to say, hey, really, I want the superclass version of set side length here, of 0 in the length, and 2 in the length. So if you mean to set side 0 or 2, I'm going to set them both. So super.setSideLength says, don't use my version here, go use my parent class version now. So we're overriding or saying, hey, my version is different than my parent class. I am a polygon, but I want to be able to do this differently here. What I'm going to do different is, hey, if it's 0 or 2, set them both in the superclass setSideLength method. Otherwise, if it's not a 0 or 2, it must be a 1 and a 3. Right, we'll set the 1 and 3. Okay, so now I don't need to do both. I can just set 0 for 5 and 1 for 10. And I can print out my small rectangle get perimeter. Notice there's a method get perimeter because we are a polygon. Rectangle doesn't define get perimeter, but because it is a polygon, it gets all of the things that polygon has. We have all of these same methods here. Now what's cool about rectangle then, we can also have a get area. we return the get side length of 0 times the get side length of 1. Right? Length times width will give you the area. Notice you don't see a get side length method. The get side length method comes from the Polygon class, get side length. So we can use the stuff from the parent class. We have all the public methods from the parent class we have access to. So we could say this is perimeter. The perimeter, and we can do the area. So perimeter should be 20, 30, right? And area should be 50, right? Oops. Oh my goodness. Okay, my settings are crazy. This compiling thing, you uncheck compile on save because my plugins stop working. All right, there we go. So now we get it actually doing a compile here. We get perimeter's 30. Oh, area's 30. Well, that's not right. Area shouldn't be 30. It should be 5 times 10, right? Shouldn't that be 50? What did we do wrong here? Yeah, we can make another square class. Yep. Get side length of 0, get side length of 1. Polygon, get side length, return, get side index. Uh-oh. We're doing something wrong here. What are we doing? Side index and length. We broke it. We broke it. The perimeter's right. Why is area not right? Oh, I'm still calling get perimeter. That's a copy-paste error. Sorry. Get area. There we go. Get area. So when I click this dot here and I get this suggestion, notice get area and set side length are bolded. They'll tell me they're from the rectangle class. The rectangle class. There's a definition of rectangle. If I look at get number of size, it says, hey, that's from the Polygon class. If I look at equals, that's from java.lang.object. So everything implicitly inherits from object. Even if you don't tell it to, everything is an object. Every class is an object. So we get some automatic inheritance that everything's an object. And we get a bunch of weird methods like equals, we get hash code, we get notify, we get wait, that all come from object. ToString comes from object as well. Right, so we're going to get area. So the ToString here, though, is horrible. So ToString plus small rectangle dot ToString. Remember, it's going to ToString automatically if you just put it in there, but that's fine. I should have done a colon. We get the name of the class at memory address. Not a very useful ToString, but we get one. This is what object does. It tells you the name of the class and where that object is stored in memory. So if I make another rectangle here, we make this one, how about big rectangle? Big rectangle, big rectangle, big rectangle, big rectangle, big rectangle. Let's do like, I don't know, 25 by 30. It's a different memory address. Right, that's where it is in memory. For the rectangle. So this one has a perimeter of 110, area of 750. So we can make different rectangles. So inheritance creates that is a relationship. So just like we know in the real world, we have things that are part of broad categories. You are a type of that category, right? Where we're all people, but then we could say, hey, there's a student category of people, there's a faculty category of people, there's a staff category of people. We can do things like that. Why we would want to do that is it helps us not reinvent the wheel, right? If all people have a name in the system, they all have a phone number in the system, they all have an email address in the system, right? Why should we write 3 different classes for staff, for faculty, and for students that include those attributes and have to do it 3 times? Right? Anytime you have the same code more than once, you should feel bad about yourself. So inheritance lets us say, hey, here's all the things that we have in common, and then I can go make a special version of it. And if I want to change the behavior, great, I can add an override to change the behavior. This is changes the behavior of the superclass version. Right, with an override. We can add new features, we can do it, we can figure out areas, we can do all sorts of fun things. Our trees were not all that interesting, sorry. Let's just try to be a basic example. Losing my stuff here. right, so what we're going to do when we build our graphical user interface application, we're going to inherit from some already written classes that are graphical user interfaces. And then we're going to say, hey, I want all of this stuff that's already done for me, and then I'm going to specialize it because I'm going to put my buttons here and my screens here, and it's going to look like this. But the basic window is already done for us. Right? We are a window, and then my special version of that window is, hey, here's everything that's on it, and here's how I act. That's why we have to talk about inheritance first. So when we start doing graphical user interfaces, we're going to take advantage of all of the pre-written Java API code, all the stuff that Java knows how to do using JavaFX, and we'll just do it. So we skipped over a lot of stuff here. Don't worry too much about it. We skipped over polymorphism. We skipped over abstract classes and interfaces. Don't worry about that. That's more of a topic for next semester if you're taking 2151. But overriding is important. Looking at constructors is important. And I think that should get us what we need here out of chapter 10. Okay? So there'll be a short quiz on 10. It won't cover all of 10, so don't feel like you've got to read the entire chapter here. Oops. Here. All right, now let's see how we're doing. So we'll use our IDE to develop a running Java program. We'll edit, compile, and run a program and use the debugger. Hopefully you've used the debugger, right? I've showed a couple times for sure. It's your friend. If it's not doing what you expect, let's run in the debug mode and see. Shadow, exclaim class for more info there. I'm teaching the course here. We'll define constants and variables with primitive data types, understand the use of the variables, the related operators, type conversions, basic input and output. I think we're pretty good on this one. So constants, right? So we have nice names to our values. Variables with primitive data types, right? Our doubles, our floats, our chars, our ints. Polygon, I mean, we could, Beta. I'm sure someone who knows more about math could tell me whether or not you can be a two-sided polygon or a one-sided polygon. Maybe. And at this point, we're just trying to use it for the example, but that's a good thought. That maybe that's not allowed. Okay, let's see. Can you make a two-sided polygon? Huh. Quora.com? Yes and no. What? They would drawing a two-sided polygon on a circle. Okay, that seems like cheating. Okay, 3 sides or more. Yeah, I think that's fair. I think that's fair. But again, that's probably more than we need. Yeah, some of the things you get on Quora are a little funny here. A hat. I have to change my hat. Oh goodness. Do I have my other one in here? Where's my other hat? There it is. You got it, my friend. Switch over to the chess bra hat. The original OG chess streamers. Go learn yourself some chess. All right. Yeah, we could. We'll talk more about exceptions when we do our miscellaneous topic week. Type conversions, right? Going from strings to ints, strings to doubles, doubles to ints, those sorts of things. Follow and write Java code that does if-else, switches, while loops. Yep, sure. Read and write to disk and files. Yep, we did that. You can write a Java class, create objects of that class with private data members, public accessor and mutator methods, and a constructor. Understand the concept of scope and variables within objects and its methods. Yeah, I think we're good. Demonstrate the core concepts of inheritance. That's what we're talking about today. We're going to use that in our project. Write and follow code that utilizes arrays. Yeah, we talked about arrays in chapter 7. And then create basic GUI programs with event handling. That's all of our objectives, our common course outcomes that get evaluated. Looks like we're in pretty good shape, I think. How you folks feeling? So the last bit here, again, we're going to pick up the OpenJFX package and the scene builder, are some tools we're going to use for building our graphical user interface applications next week. Stretch. Oh, my friends. Oh, thank you. That was good. This loft bed is actually really handy. All right, so next week we'll start. We're not exactly going to follow the way the book does it because we're going to use Scene Builder. Shadow, it's free for you to watch. If you'd like to get a grade, you need to be an enrolled student at my college. So up to you. You don't know when you installed it, Zero? I don't know. Yeah, it's a great tool. So we'll look at the topics, but we're going to use Scene Builder. The book doesn't show you Scene Builder because reasons. We're switching books next semester, thankfully, to a cheaper book, and it does use Scene Builder. So next semester we'll pick up on that, and then you'll have a better reference here than just me showing you things. But it's actually really easy to use. It's really fun and easy to use. I'm a big fan of building GUI applications. They're much more interesting than just typing stuff out of the console. So we'll talk about stuff from Chapter 12, the final project. We'll talk about stuff from Chapter 13, how we do it in Scene Builder. Miscellaneous topics. This will be relatively short. I want to talk about exceptions, anything else, any other questions you folks have. 8:16, totally dedicated for the final project work time. I have no lecture plan, so I won't be live. If you folks want to meet, we can meet during class time. That's fine. If I meet other times, regular office hours, that's cool too. And then at 8:23, coming up a little more than a month from now, we'll do our final project presentations on Zoom. Every individual or pair can get together and present their work. We can take a look at how everyone else approached it. We can ask a couple questions. And if you present it, I'm able to grade it live while you present. I'll ask you, hey, show me this feature, and you'll do this thing, and you'll get the points. So it works out relatively nicely for that as well. So it's been a lot of fun. We are winding down then, just a couple weeks left. 3 more weeks of me talking topics to you. More lectures, 3 more weeks of lectures. And then a little bit of final project work time, and then you folks get a chance to talk and present. And we should have a lot of fun. That's it. Again, we cover Chapter 10 lightly. You pick more up on that next semester, so we don't need to get into all the stuff in the chapter there. So sort of just a breeze through, looking at what that extends keyword is, how we have to call constructors, that sort of thing. And then we're good to start GUI applications. Yeah, everyone gets to present. Yep. If you don't present, you don't get a score for it. So if you can't make it that night, hopefully you've already contacted me, or can arrange to present at a different date and time for me. But because I know it's been asynchronous optional, or synchronous optional, asynchronous optional, whichever you prefer. So if you can't make it that night, then we can arrange for another time to present. But I do need you folks to present your projects to me. That's part of doing this. Awesome. That's all I've got tonight. Again, it's going to take a little bit of practice. These keywords are a little funny here. You can go through some of the exercises in the book. You don't need to hit all of them because we're skipping some of the topics there. And we go from there. I'll work on getting your midterms and those projects scored. We'll have a quick quiz on Chapter 10. Mostly the stuff we talked about from lecture. And probably do a quiz on 12. I don't think we'll have a quiz on Chapter 13. So we'll finish up the quizzes pretty soon. It's just awkward to have questions about the GUI topics. But 12, I think we'll have enough. Cool. All right. Any other thoughts, questions, concerns? Don't forget, do get the midterm in by 11:59 p.m. tonight. Sorry for the back and forth and changing my mind on the 4-hour time limit, but no one complained. So hopefully it just worked out in your benefit, that you had a little more time to work on some of that. I got behind on getting things back to you and wanted to give you that benefit. Yeah, I'll post the Chapter 10 quiz in just a little bit. I have to go in and post it. Cool. All right, I do have office hours tonight. If you folks want to meet, we can chat about whatever's going on. Don't forget, next study group is Wednesday. Wednesday, 5 p.m. Hopefully that's going well for you folks. Mr. Tim said that we got a pretty decent crowd who usually makes it, which is awesome to hear. I'm really glad he's able to come out and be our supplemental instructor. All right, lost a little bit of my connection there. Uh-oh. All right, good time to end then. Let's go see who else we can bother out in Twitch land, and we go from there. Let's do our ending here in a second. Maybe we can hold on to our bits for just a minute. Let's see. Oh, Rob's away. Oh, there's like no one else online. My goodness. No one I know is online. That can't be right. Is that right? Oh, here we go. Ooh, Professor Burrows. Let's check out N. Burrows. I don't know why I don't have her followed. All right, folks, you take care. We'll see you around. Be on next week. If you don't drop by my office hours, we'll chat. Take care, everybody.